To the channel. So in this video again we are going to discuss JAM Economics 2020-22 and the matrix and linear algebra questions, right? So let's start with the first question, question number 6. So in this question, given this our the vector space is V R3, right? So I can say that dimension of R3 is 3. So dimension of vector space here is 3. And they say this W is a subspace of R3. But the point here is the dimension of W is not mentioned. It is a subspace of R3. So the possibilities are W is a subspace of dimension 1 or dimension 2 or dimension 3, right? So all three possibilities are open here. So that simply means like the basis can contain one element, can contain two element, and can contain three element. So if you look at the options, in option A we have two elements, option B we have four element, option C and D we have three elements each. So clearly option B cannot be true because it contains four elements, right? And the basis can contain at most three elements. So this is not true, as basis can contain at most three elements, right? And in which case it will contain three elements when dimension is 3. So option B is not correct. So now let me check about option A. So I will only check whether given set of elements like 1 2 1 and 1 minus 2 5 are they linearly independent or not. So our vector v1 here is nothing but 1 2 1, and vector v2 is nothing but 1 minus 2 and 5, right? So we can clearly say that v1 and v2 are not scalar multiple of each other, right? This is clear to everyone. Like they are not scalar multiple of each other. So like you can see the first entry, first tuple of both is 1 1. So it should be like multiple of 1. But the second tuple become 2 to minus 2. So it's a multiple of minus 1, right? And we don't have a common multiple between v1 and v2. So we can say that v1 and v2 are not scalar multiple of each other, hence independent. So that means this can be a possible basis if dimension of W is 2. So I will write here it's a possible basis if dimension of W is 2. Similarly, we can check, we will check for the option C, right? So here we have three vectors v1 which is 1 1 1, v2 which is 1 2 3, right? And v3 which is 2 minus 1 1. So to check whether they're linearly independent or dependent, the best possible way for me is just to find out the determinant, right? So I will have a matrix, say, so I will say like determinant of M, where M is the matrix where I can write v1, v2 and v3 as the column vectors, right? So it's become determinant of 1 1 1, 1 2 3, and 2 minus 1 and 1, right? So determinant is nothing but 2 plus 3, then we have minus of 1 here, and then it's become like 1 plus 1. I hope determinant, everyone know like how to find out the determinant, right? So this become nothing but 3 minus 2. So what is the final value here we have? So it's like 5 minus 2 which is 1 not equals to 0, hence linearly independent. Hence linearly independent. So I can say that it's a possible basis if dimension of W is 3, right? Similarly, we can check for the option D. So in option D, we have, I will use the same method, the matrix determinant method. So determinant of M is nothing but the first vector will become first column. So 1 minus 2 1, and you can like keep vectors in row as well. That doesn't make any difference here. So we have 2 1 and minus 1 here, and then we have 7 minus 4 and 1, right? So let's find out this determinant. This is nothing but 1 times 1 negative 4, 1 minus 4, then negative of 2. This will become negative of 2 and then plus 4, right? And then we have plus of 7, and this is coming out to be 2 minus 1, right? So this is nothing but negative of 3, negative of 4, plus 7, 0. Hence LD, linearly dependent, right? And if the vectors are linearly dependent, so they cannot form a basis. So here it's clearly not a basis. That means, so here two options can be correct one, option A and option C, right? But this question belongs to the first part where only one answer can be correct. That's why, but here two answers are coming correct, like A and C. Okay, so that's why they decided to give marks to all the students for this question, right? So now let's come to this question number 41. This is a very easiest question if you know, if we people know one single fact, right? And the fact is, the sum of all eigenvalues of a matrix, sum of eigenvalues of a matrix is always equals to trace of a matrix, right? So what is trace? Trace is defined only for a square matrix, and it is sum of all principal diagonal entries, right? So here principal diagonal contain entries like this. This is principal diagonal 1, 5 and 1. So this is coming out to be 1 plus 5 plus 1, which is nothing but 7. So sum of all the eigenvalues is also gonna be 7. That's all for this second question. Now let's move to the third question. Okay, so they say let the system of equation be alpha times u plus w is equals to 0, right? And second equation say u plus something v, alpha v is equals to 0. And third equation say we have v plus alpha of w is equals to 0. So for me, this is nothing but a system of linear equation, right? So if you want to write it again, I can say that alpha times of u plus 0 times of v plus w is nothing but 0, right? This is u plus alpha times of v plus 0 times of w is equals to 0, and this is nothing but 0 times of u plus 1 time say v 1 times of v plus alpha times of w is equals to 0, right? So in the like matrix form, this can be written something like this: alpha 1 0, 0 alpha 1, and then we have 1 0 alpha, right? And this multiply with u, v and w is equals to 0 0 0, right? So first of all, this is a homogeneous system of equations, right? So this is a homogeneous system of linear equations, right? And we know that this homogeneous system of linear equation have infinitely many solutions. If I can say this as like a times x is equals to 0, right? So if rank of a is nothing but less than number of variables, right? So here number of variables is 3. So the rank should be less than 3. Whether it is 1 or it is 2, that doesn't matter. So if rank is not equals to 3, this simply imply So as rank of A is not equals to 3, this implies the determinant of A should be 0. Okay, let's find out the determinant of A. If we find out the determinant of A, this is nothing but alpha times alpha square minus 0. And then we have 1 times 1 minus 0 is equals to 0. And this gives me the equation of alpha power 3 plus 1 is equals to 0. So I can say that this given system of linear equations have infinitely many solutions if and only if alpha power 3 plus 1 is equals to 0, or you can say that alpha power 3 is equals to minus 1, or you can say that alpha is nothing but negative of 1, right? So negative of 1 is the correct answer for this question. So I hope if you if these solution like you are able to understand the solutions, please like this video. Thanks for watching. Bye bye. Take care all of you.